All right, we are jumping into 4.13. This is the last section of our formal study of proofs. We'll continue using proofs, but this was the chapter where we're just doing proofs just to do them. So it says, we have learned how to prove triangles are congruent and how to use CP/CTC after determining the triangles are congruent. The following is putting everything together. So this first part says, with these two, or with the diagram on the right, draw all of the possible triangles you think look congruent, like that you could probably, hopefully work with. So in this one, you have like this flying airplane look. Those two triangles we might be able to work with. The next ones would be those little triangles at the bottom. And then you can look at the whole entire left triangle and the whole entire right triangle, which make the whole entire figure. And those are the three pairs of triangles that we could probably work with. It says, look at the proof below. What triangles do you know you are going to end with? Explain. So in the end, we are trying to show that angle DCE and angle DBE are congruent. When you look at DCE, that's what it said, DCE, DCE, and DBE, you could see that those are going to be how I listed those out, the left triangle, the middle triangle, and the right triangle in problem number 1. You know you are going to be ending with the middle two triangles. Those are the only triangles that have those angles as parts of them, and that's how you would use CP/CTC. Okay, so it's going to be DCE and DBE because they are the triangles that have those angles. Do you have enough information to go straight to that? So if you drew those out, you can see the marks that I put. You had the reflexive property and you had a given, and the answer is no. You do not have enough to be able to work with those triangles directly. So the question is, are there other triangles you can work with first so that once you find out that those triangles are congruent, you would be able to steal parts of those and through CP/CTC and learn about the triangles you do care about. So when we look at this, I can see that I would like to show that the triangles ACD and ABD are congruent, because once I can show those are congruent, then I'm going to be able to say the bottom sides are congruent, which is going to give me extra information about the triangles I actually care about, which is DCE and DBE. Okay. What I really should have done here, I wish I put the markings on, is show you what we had for all three sets of those triangles to see which ones we could work with. Now, let's take a look at how I did this. I went over and only used the givens that I wanted to work with first. I am going to be looking at triangle CAD and BAD. Trace those out and see the two triangles. It's the top left and the top right triangle. We have a given. We have a given for the angle bisector, so that gives us angles are congruent, and we have the reflexive property. When you get all that together, you find out those two triangles are congruent by AAS. Now, those triangles do not have what we're trying to prove, angle DCE and angle DBE, as part of them. So, therefore, the only reason we prove those are congruent is because we want to steal parts of those triangles that help us with the bottom two triangles. And the only parts of the top two triangles that help us with the bottom two triangles is side CD and DB. So that's why I pulled that from CP/CTC. Once you know that those sides are congruent, you could state the other given, that CE is congruent to EB. That's given. And you also have the reflexive property. Now you can say that those bottom triangles are congruent by SSS. And once you know those triangles are congruent, you're going to use CP/CTC. So the main things you need to know here, we don't end up having a quick notes, but you want to figure out what triangles you could work with, then figure out what triangles you know you're going to end with, and try to go directly there. You might have enough information. If you don't, then you have to work with other triangles first, and then steal from those triangles to work with the ones that you actually want to work with. The other thing is, make sure that you're not stating certain givens or parts of a proof until you actually need them. In this, you can see I did not say CE is congruent to EB at the beginning of the proof because it had nothing to do with those two triangles. It had to do with the other triangles. So that's basically it. It is you are going to be oftentimes working with two different triangles that you don't think you care about first, and then using those triangles. So in this case, name all possible sets of triangles that appear to be congruent. I see that there's like this, the overlapping triangles, CAD and CEB, and you also have the bow tie proof that you could possibly be working with. Look at the proof below, and what triangles are you going to end with? So it is BF and FD. BF and FD are parts of the bow tie proof, the thing that looks like a bow tie, not the overlappers. They're not even sides of the overlappers. So you would want to probably first see if you can just go directly to the bow tie. You have the given AF and FE, and you have the vertical angles theorem. Unfortunately, you are missing something. So that's not going to work. So what we're going to do is we see if we have enough information to work with the overlapping triangles, CAD and CEB. And when you look at that, you find out, if you draw everything out, you can see that I put the two givens, and then you had the reflexive property, and those triangles would be congruent by SAS. So what we do here is you only put the givens down that you need at that time. So you have a given for the overlapping triangles, another given, and the reflexive property. That states that the two triangles are congruent by SAS. Now we have to figure out what parts of those triangles would be helpful. Would it be that last side? No, that last side is more than one of the sides of the bow tie proof, so that's not it. And then you keep picking angles and sides and figure out what is helpful. We find out here that angle A and angle E are going to be the ones that are going to help us. If you take the bow tie proof, you put the givens you had, and then also say angle A is congruent to angle E, as you can see up. Let's see where I in the original diagram, you could see we had the sides congruent. You also had the vertical angles theorem. If you also throw angle A being congruent to angle E, then you can see that the triangles would be congruent by ASA. And why do we care about those triangles? Because BF and FD are parts of those triangles. So we can say they are congruent by CPCTC. All right, hopefully that made sense. This is the last section because it is the hardest. So if you're like, ooh, this is tricky. Yeah, it's tricky. Let's take a look at the homework. So the homework on this first one, you have to figure out what two triangles look like they are congruent. So it looks like the bow tie and the overlappers are congruent. In the end, we want to show AD and BD are congruent. AD and BD are parts of the bow tie. So if you try to go straight to the bow tie, you can see the marks I put. The sides are congruent, the vertical angles, but you don't have enough. So no, we only have one pair of sides and vertical angles. So we know we're going to do the overlapping triangles first. And once we have those overlapping triangles congruent, we can steal parts of those overlapping triangles, figure out if it's two angles that are helpful for the bow tie or if it's two sides, and go from there. So first things first, I prove that the two triangles that are overlapping are congruent. We have right angles which are congruent, we have the reflexive property, and we have the given angles. So those are going to be congruent by ASA. You can see that in my proof. Now you have to look. Is it the left side and the right side being congruent that I want to use for CPCTC? Well, if you put that on the bow tie proof, then you have SSA, and SSA does not work. So that's not it. The other part would be the hypotenuses. No, the hypotenuses are too big to be parts of the bow tie proof, so that's not it. So then you look at angle A and angle B, which are parts of these right triangles, and they are also parts of the bow tie. And I say, yes, if I had that, then the bow tie proof would be congruent by AAS. And that's where I went. I went over and said angle A needs to be congruent to angle B by CPCTC. You have the given that's part of the bow tie proof. You have vertical angles for the bow tie proof. The bow tie is going to be congruent. Those two triangles are congruent by AAS. And lastly, parts of those triangles are congruent by CPCTC. All right, hopefully this made sense. Once again, it is challenging. You want to figure out what triangles you can work with, what triangles you know you're going to end with. Can you go directly there? If not, what triangles can you work with first so that you can harvest things out of those triangles? And then after you harvest things out of those triangles, you are going to be able to continue with your proof. Sometimes you have to work with things you don't think you're going to work with first so that you can finally work with the triangles you want to. All right, hopefully that made sense. Thanks for watching.